The sanctions worked. TSMC stopped shipping. ASML stopped shipping. Lam Research, Applied Materials, KLA, all stopped shipping. The entire apparatus of American export control came down on China's semiconductor industry like a controlled demolition, and then China opened a new chip factory. Not a prototype, not a pilot line, a factory. SMIC's facility in Shanghai, running what the company calls its N+2 process node, functionally equivalent to a 7-nanometer class chip, began volume production in 2023. The world found out not through a Chinese press release, but through a Tech Insights teardown of a Huawei Mate 60 Pro. A Canadian research firm, reverse engineering a phone, accidentally revealed that the most aggressive export control regime in American history had a gap in it wide enough to ship a flagship smartphone through. Washington released a statement. Then another one. Then a third. China shipped more phones. This is where most analysis stops, at the embarrassment. But the embarrassment is actually the least interesting part of what happened here. Because if you look at what the sanctions produced over the 2022 to 2025 period, you find something that should genuinely unsettle anyone who believes that economic pressure is a reliable foreign policy instrument. The controls didn't freeze China's chip industry. They restructured it in ways that are now significantly harder to reverse than the original problem ever was. Before October 2022, China's semiconductor industry was fragmented, dependent, and in many ways comfortable with that dependence. Chinese firms bought American equipment, Japanese materials, Taiwanese foundry capacity, and South Korean memory. The supply chain worked. Nobody had a strong incentive to build domestic alternatives when the international ones were cheaper, faster, and better. SMIC was growing, but it wasn't racing. Huawei was designing world-class chips, but having them made in Taiwan. Then the controls hit, and something unexpected happened. The incentive structure of an entire industry flipped overnight. Suddenly, every Chinese chip firm that had been quietly content with foreign suppliers had a gun to its head: find domestic alternatives or die. State capital, which had been flowing lazily through the China Integrated Circuit Industry Investment Fund since 2014, got a direction. Engineers who had been building careers at multinational firms started getting calls. Universities that had been producing talent for export started retaining it. The Big Fund, that's the colloquial name for the National Semiconductor Investment Vehicle backed by the Ministry of Finance and the National Development and Reform Commission, deployed a third tranche in 2023, reportedly north of 340 billion yuan. That's roughly $47 billion, directed specifically at filling the gaps that American sanctions had just mapped out for them in extraordinary detail. Here's the part worth sitting with. The export control lists that Commerce published, entity list additions, the foreign direct product rule expansions, the October 7 rules, those documents told China's planners exactly which technologies were considered most threatening. It was, unintentionally, a fairly precise roadmap of where to invest. You couldn't design a better industrial policy signal if you tried. The question this video is really asking isn't whether the sanctions failed. They clearly underperformed. The question is whether they failed in a recoverable way, or whether the attempt itself accelerated the very outcome it was trying to prevent. That answer is more complicated. And the complications start with a company most people outside the industry have never heard of. The company is Huawei, but not the Huawei you think you know. Most people's mental model of Huawei is frozen somewhere around 2019, the telecom giant, the 5G controversy, the CFO arrest in Vancouver, the entity listing. That Huawei was a hardware assembler at scale, brilliant at systems integration, dependent on outside silicon, growing fast but not vertically sovereign in any meaningful sense. When the chip sanctions hit, the consensus read was that Huawei was finished as a technology competitor. Its chip supply was cut. Its phone business collapsed. Revenue dropped 29% in 2021. The patient appeared to be bleeding out. What happened instead is one of the more remarkable industrial pivots of the last decade, and it received approximately 1/10 the coverage it deserved. Huawei didn't just survive the sanctions. It used the period of near death to rebuild itself as something the original company never was. A vertically integrated technology ecosystem with its own chip design, its own operating system, its own cloud infrastructure, and now its own developer base. Harmony OS crossed 900 million devices in 2024. Huawei's HiSilicon division, which most analysts had written off as a fabless design house with no future, became the internal engine of a closed-loop technology stack that Beijing is now actively trying to replicate across other industries. The Mate 60 Pro wasn't just a phone. It was a proof of concept, delivered deliberately on the one-year anniversary of the October 7 controls. The timing was not accidental. Now here's where the mechanism gets interesting, because the Mate 60 story is frequently misread. The chip inside, the Kirin 9000 seconds, produced by SMIC on that N+2 node, is not competitive with TSMC's 3-nanometer process. It's not even close to Apple's A17. On raw performance per watt, it trails by a significant margin. The people who called it a complete sanctions failure were overreading. The people who dismissed it as irrelevant were underreading. What it actually represents is a threshold crossing, not performance parity, production viability. SMIC demonstrated that it could manufacture a 7-nanometer class chip at volume sufficient to go inside a commercial flagship device. That is a categorically different thing from a lab demonstration. Volume production requires yield management, process stability, defect control across thousands of wafers. Those are hard problems. SMIC solved enough of them to ship, and they did it without EUV lithography, the extreme ultraviolet machines that ASML makes in the Netherlands, that the Dutch government blocked from export to China under American pressure. SMIC used multi-patterning techniques on older DUV equipment, deep ultraviolet, essentially taking a less advanced tool and running the same layer of a chip multiple times to achieve finer resolution. It's slower, it's more expensive per wafer, the yields are lower, but it works. The sanctions assumed EUV was the choke point. It was, just not an absolute one. This is the reversal that changes how you have to read everything that came before. The American export control strategy was built on a theory that there exist certain critical nodes in the semiconductor supply chain that are so technically complex, so geographically concentrated, so capital-intensive to replicate, that denying access to them would impose a ceiling on Chinese chip progress that couldn't be engineered around. Choke the tools, choke the progress. That theory is not wrong. It just had a different timeline than anyone modeled. Because the other thing the sanctions did, and this is the part that gets almost no coverage, is drive Chinese investment into equipment manufacturing itself. Nora Technology, AMEC, King Semi, these are Chinese semiconductor equipment companies that barely registered in Western trade analysis before 2022. By 2024, Nora had crossed into the top tier of global etch equipment suppliers by volume. Not by capability, volume. They're selling domestically at a scale that is building institutional knowledge, manufacturing experience, and process data at a rate that wasn't happening before the sanctions gave them a captive market. You cut someone off from the best tools. They start making worse tools, then slightly less worse tools, then tools that are good enough for most of what they need. The timeline compresses every year, and Washington is now in the uncomfortable position of having to sanction not just American firms selling to China, but third-country firms using American technology to do the same thing. The foreign direct product rule expansions tried to solve this. They created their own problems. We'll get to those. Here is the strongest counter-argument to everything I've said so far, and I want to give it a fair run before I explain why it's incomplete. The counter-argument goes like this. Yes, China has made progress. Yes, SMIC shipped a 7-nanometer class chip. Yes, Huawei pivoted impressively. But the gap at the frontier, at 3 nanometer, at 2 nanometer, at the leading edge where AI accelerators and the most advanced logic chips live, that gap is not closing, it's widening. TSMC and Samsung are pulling away faster than SMIC can follow. NVIDIA's H100, the chip that actually matters for the AI race, requires process nodes and packaging technologies that China cannot currently replicate at any volume. The sanctions on this reading didn't fail. They just succeeded at a different layer than most people were watching. That argument is serious. It deserves to be taken seriously. And it's about 60% right. The frontier gap is real. China's most advanced domestically produced AI accelerator, Huawei's Ascend 910B, benchmarks at roughly half the training throughput of an H100 under comparable workloads, according to analysis published by SemiConnectors in late 2023. That is a meaningful deficit when you're trying to train large language models at scale. The compute ceiling matters. And right now, China is bumping against it. But here is what the 60% right argument misses. It assumes the frontier is fixed. It assumes that the AI workloads of 2025 require the same chip characteristics as the AI workloads of 2028. And it assumes that China's response to a compute ceiling is to try to climb the same ladder, when the actual response has been to build a different ladder. Baidu, Alibaba, and a cluster of Chinese AI firms have been publishing research since 2023 on model efficiency, specifically how to extract more performance from less compute. This isn't altruistic, it's adaptive. When you can't get more chips, you make the chips you have do more work. Some of that research is genuinely impressive. The architectural innovations coming out of necessity look, in places, like the kind of efficiency work that American labs only started prioritizing once inference costs became a business problem. Necessity, historically, has a reasonable track record as an innovation engine. Now bring in the Foreign Direct Product Rule, the FDPR, because this is where the sanctions story gets genuinely complicated, and where American policy started producing costs it didn't fully account for. The FDPR expanded significantly in October 2022 and again in October 2023, essentially says, if a product anywhere in the world contains American technology above a certain threshold, software, equipment, design tools, the U.S. government can restrict where that product goes. It extended American jurisdiction extraterritorially into supply chains that don't touch American soil. The intended target was China. The actual blast radius was wider. Japanese equipment makers, Dutch lithography suppliers, South Korean memory firms, all found themselves navigating an American regulatory framework that they didn't vote for and didn't design, applied to their own products made in their own countries. Some complied fully. Some complied partially and quietly carved out exceptions. Some started asking, internally, whether their long-term dependence on American technology standards was a strategic liability. That last question, that quiet, internal question being asked in Tokyo and Seoul and Eindhoven, is the one that doesn't show up in the sanctions scorecard. But it is the most important question the FDPR produced, because the coalition that American semiconductor leadership depends on, the alliance of TSMC, ASML, Tokyo Electron, Samsung, SK Hynix, is not a formal treaty. It is a network of commercial relationships, shared standards, and accumulated trust. It holds together because participating is more valuable than not participating. The more the U.S. uses that network as a foreign policy instrument, the more it asks allied firms to absorb costs, lost contracts, legal complexity, market uncertainty, on behalf of American strategic goals, the more that calculus shifts. Not dramatically, not immediately. But at the margin, every year the question gets asked again. China, for its part, has been patient about this. Methodically patient in a way that doesn't get enough credit. The response to the FDPR wasn't a tantrum. It was a procurement surge before the rules tightened, a domestic substitution push after they did, and a quiet campaign to offer Chinese equipment and Chinese standards to any country that found American extraterritorial reach uncomfortable. There are markets in Southeast Asia, the Middle East, and parts of Africa where that offer is landing. The sanctions were supposed to isolate China's chip industry. Whether they've also, slowly, begun to isolate American semiconductor diplomacy, that's the question. Let me tell you where this actually lands, not where the press releases say it lands. The American semiconductor sanctions of 2022 through 2025 were the most ambitious export control regime attempted since the Cold War-era COM restrictions on Soviet technology transfer. They were architecturally sophisticated, diplomatically coordinated, and genuinely disruptive to Chinese supply chains in the short term. The people who designed them were not naive. They understood choke points. They understood dependency mapping. They did serious work, and they solved the wrong version of the problem. The assumption embedded in the entire framework was that China's chip ambitions could be managed, slowed to a pace where American technological leadership would remain structurally decisive. The controls weren't designed to stop China permanently. They were designed to buy time. Time for American firms to pull further ahead, time for allied coalitions to solidify, time for the next generation of American chip architecture to cement an unassailable lead. What they didn't adequately model was what China would do with that same window of time. Between 2022 and 2025, China's domestic semiconductor equipment market grew at a rate that outpaced every pre-sanction projection. The number of Chinese engineers working on EDA tools, the software that designs chips, crossed a threshold where domestic alternatives to Synopsys and Cadence are no longer theoretical. They're shipping, they're limited, they're being used. Empyrean Technology, a Beijing-based EDA firm, signed deals with over 40 Chinese chip design houses in 2024 alone. Not because their tools are better, they aren't yet, but because those design houses can no longer afford to find out what happens if American EDA licenses get pulled next. That's the dynamic the sanctions inadvertently hardwired into Chinese industrial behavior. Not defeat, redundancy, build the backup, make the backup good enough, then make it better. Here is my read, and I'll be direct about where I'm confident and where I'm extrapolating. I'm confident that China will not reach leading-edge parity with TSMC within 5 years. The process physics, the equipment gaps, the material science challenges at sub-3 nanometer nodes, those are real barriers, not paper ones. Anyone telling you China is 2 years from matching TSMC's N3 process is either misinformed or selling something. I'm also confident that parity at the frontier is not actually the goal that matters most for the next decade. The AI compute race, which is the real stakes underneath all of this, is not purely a chip fabrication race. It is a systems race. Chips, interconnects, memory bandwidth, software stacks, model architectures, energy infrastructure. China is behind on the first. It is competitive or ahead on several of the others. The outcome of that race will not be decided by who has the best lithography node. It will be decided by who assembles the best system. And on system assembly, on the unglamorous, grinding work of making everything work together at scale, China has demonstrated repeatedly that it is willing to absorb short-term pain for long-term structural position in a way that quarterly earnings-driven American firms structurally cannot match. My prediction, and I'll stake something on this, by 2028, the conversation will have shifted. The debate won't be whether China can make advanced chips. It will be whether the definition of advanced still means what it meant in 2022. If Chinese AI firms, working with domestically produced, less efficient hardware, produce model architectures that close the performance gap through software efficiency rather than silicon brute force, the entire sanctions framework will need to be reconceptualized from the ground up. Washington will release another report at that point. Beijing will respond by shipping more chips. The open loop from the beginning of this video, that factory that wasn't supposed to exist, it's worth returning to now. Because the factory isn't the point. The factory is the symptom. The point is that the conditions which made that factory possible, the capital, the engineers, the institutional knowledge, the political will, those were all assembled inside the window that the sanctions were supposed to close. That's not an argument against sanctions as a tool. It's an argument for being precise about what tools can and cannot do. Economic pressure can impose costs. It cannot, by itself, change the direction of a state that has decided where it is going. China decided in 2015. The sanctions arrived in 2022. That's a 7-year head start that no export control list can retroactively close. If this reframed something you thought you understood, share it with one person who'd find it uncomfortable. That's the only metric that matters.